Welcome everyone to the ProScaleE webinar. Today we're going to go through the ProScaleE method for accounting for ecotoxicity in life cycle assessments and safe and sustainable by design. My name is Geneviève De Bauw and I will be your moderator today. I'm a partner with Rydberg Partners, a boutique consultancy specializing in sustainability that has been supporting the development of ProScale since 2016. We have quite a heavy agenda today. About a year ago, we held the first webinar that introduced ProScale, the enabling method providing a way to account for human toxicity in LCAs. But since last May, a team has worked intensively to develop ProScaleE, the variant of the method that tackles ecotoxicity. We're happy to present this new application of ProScale to you today. As I mentioned, this will be quite a dense session. We will first go through an overview of the key features of ProScaleE, and then we'll explore case studies, research activities, and the integration of ProScaleE in LCA software and SSbD tools. We'll have a short break around at the end of the first round of the presentation to take some questions, and we'll also seek to take some questions at the end of the second session. A little note about the consortium member of ProScale. This project was initiated in 2016 by a group of companies working together with IVL that act as the scientific secretariat and is now hosting this project. The consortium has since welcomed a couple of new members and it is still open for participation, as will be discussed later today. So here we have the names of the current consortium participants. I'd like, before we start the meat of the subject, to thank our sponsors. We're very grateful to the following sponsors that have made the organization of today's webinar possible. Financial support via the European Union through Project Calimero and Kimat Sustain, the Swedish Research Council for Sustainable Development in the form of the Formers Grant, and the Swedish Foundation for Strategic Environmental Research with the Mistra SafeChem project for financial support. Okay, so before giving the floor to the speakers, a few recommendations to make the most of this webinar. If you have questions, please use the Q&A box. We will take time after each round to go through these questions and allocate them to speakers. Please also note that a recording of the webinar will be made available on the IVL website after the event. Without further ado, let's dive into today's topic with Martin Klatt, who will give us a background briefing on ProScale and ProScaleE and their raison d'être. Martin is the head of product stewardship, dispersions and resins Europe, and the REACH coordinator and global legislation coordinator of the operating division dispersions and resins at BASF SE. Thank you, Martin. Floor is yours.
Thank you, Geneviève, for this kind introduction, and it's a pleasure for me to be here and have this introductory presentation on ProScaleE. And you see there is also another term which is called ProScale, and since this is an initiative which is already some years old, I would like to give you a little bit of a background and also of the history of it. In the year 2016-2017, there was the indication that the construction product regulation will require toxicological data for the environmental product declaration. Environmental product declaration is a tool to show the sustainability of construction products, and it's a requirement in the construction product regulation. The only available tool at that time was called USETOX, and I will come to that as well. And all the industry players felt that UseTox is not an adequate tool to describe risk coming from chemistry in a life cycle perspective. And therefore, a little group of experts that was driven first by BASF and some life cycle risk assessment consultants from third parties tried to develop a conceptual idea how to derive data for the chemical risk for a life cycle assessment. And that was then brought to an industrial consortium. There was a big webinar. At that time, it was even a face-to-face meeting in Brussels, where we went outside and then promoted, at that time called ProScale, as a tool for life cycle and toxicological risk assessment. And the members of that consortium are still members as of today, including then IVL as the supporting partners. So in October 2017, as I said, that was more or less the kickoff of ProScale. And now we have 31st of May 24, which tells you almost 7 years later, we have now the official introduction of ProScaleE to a wider audience. Next slide. So what is the objective behind that tool? I told you in the past, we only had UseTox to assess toxicological risks for life cycle assessments. And now we said we need something which is easy to use. Whenever you have tried to make a UseTox assessment, you will identify big problems because it's a very complex approach. And in the end, you don't know anything. You don't know the risk drivers. You have no correlation between chemistry and risk. And that was the objective. We wanted to have a tool which is easy to use by using available data sets. You should immediately identify the risk drivers in the life cycle scenario of making a product. And also you should have the correlation between the chemistry and the risk. What does it mean? If I make a product, I can use two different raw material sets. And if they have different hazard potential, one should come out worse than the other. And that is very easy to do with ProScale, and that was also one of the objectives to develop that tool. So as I said, ProScale was then the invention as a method for human toxicity assessment and life cycle assessment. And it was only focused for human toxicity. It's called ProScale only. Now we talk about ProScaleE. Maybe this one is shorter than called ProScaleH for human toxicity. And then it should take into account all chemical risk-based elements in an LCA of a product, and should also prevent a hazard-only assessment because we always wanted to take the risk part into consideration. Next slide. So life cycle assessment, I guess many people of being here in the audience know life cycle. In principle, it's a full view on a product which you make from the raw materials production until the end of life of the product. You have process, maybe one process, maybe many processes in between. You have input materials, you have output materials, and then you compile and evaluate all the inputs, all the outputs, and see what are the potential environmental impacts and the potential human health impacts throughout the life cycle. Next slide. Why was that so important? As I said, the environmental product declaration, which is coming from the construction products regulation, and product environmental footprint, which was an initiative by the Commission starting a little bit later, was the driver. And this is also something which is very important for the future. You probably all have heard about the Eco Design for Sustainable Products regulation. And there also PEF is one tool to declare or to assess sustainability of a product. So if you look at the those things, if you look at the environmental product declaration or product environmental footprint, you see many impact categories. One are very obvious, like climate change, resource depletion, ozone depletion, water use, but you also see toxicity endpoints, human toxicity, ecotoxicity. Next slide. If in the end, what you want to have an assessment of all endpoints, including the toxic assessment. And then you can compare products and make your decision which product is better from a sustainability and life cycle point of view, including human toxicity. At that time, that was ProScale. And in the future, we will also have ecotoxicity as an additional tool. Next slide. So I told about USTOX, and now we have ProScale, and I called it ProScaleE, because that is a ProScale in the past, which was taking into account human health only. The ProScaleE is really the direct human toxicity when it comes from raw material, production, use, service life, end of life. You directly check what is the impact to human health of all that story. If you go to USTOX, it's more or less an indirect assessment. It's more the assessment of humans via the environment and ecotoxicity for long term. And that is the reason why for USTOX, very often you cannot identify the risk drivers. And that is something which we wanted to avoid with ProScale. Next slide. So what is ProScale in detail? And you will see this type of slide also for ProScaleE. And that is very important. So we wanted to have the approach very similar. We have things which are very much related to substances. We have impacts which are related to the process, and then we have impacts which are more related to the product. And they all are multiplied and they give the ProScale factor. We have a hazard factor, that is the hazard potential of a substance in the process as a raw material, as an emissions of a substance during the process, or emission of a substance during life cycle. Then we have the process-specific ones, and for the process-specific ones, we have the exposure concentration factor and the person-hour factor. So in principle, the exposure factor is more or less exposure modeling from which we said we wanted to use easy to available data. That's the reason why we were saying let's use ecotoxicological. And the person-hour factors tells you how many hours a person is in contact with a substance when making a product. So that is the exposure part. And then we have the mass flow, which simply tells you how much kilogram of a substance is needed to make the finished product, because that is also important. And if you multiply all these numbers, you get the ProScale number, and it's a very easy approach. And you will see, and there will be one of the next presentations, the same approach for ProScaleE. Now, what is the possible use? First of all, EU or national policy. I told you already the PEF, the product environmental footprint, will be a very important tool when it comes to the eco design for sustainable products regulation. So that is the tool to assess sustainability coming from chemical risks and also taking into account many endpoints, many more than only toxicology. We have safe and sustainable by design as a new principle of the Commission to develop a more sustainable chemistry. And here you also need a tool to say what is a sustainable chemistry. And then ProScaleE and ProScaleE could help. REACH and CSS in general is the strategy of the Commission to make Europe more sustainable. And again, you need a tool for chemical risks, and that would be ProScaleE, ProScaleE. EPD, as I said, for the construction product regulation, it's very similar to the PEF from the endpoints. But that's national and regulation, but also at company level. Companies want to decide what is a more sustainable substance when it comes to chemical risks. And here ProScaleE and ProScaleE will be the tool of choice, because it's very much a good relation between the chemistry and the outcome of the sustainability endpoint, toxicity or ecotoxicity. It can also be used to answer customer questions. What has more impact to environmental toxicity aspects? or also can check for value chain risk tracking. If you see raw materials of high hazard potential, these will be identified in ProScale, and therefore you could work on getting a different process by changing the raw materials. Next slide. So you saw this picture already. We have ProScaleH, we have use talks. Now we said that's not enough. We have to go to environment as well, and we want to develop ProScaleE. And in principle, we have now ProScaleE. Whatever we do in a process, we create release to environment, and that has the potential for ecotoxicity. And that assessment will be ProScaleE. You also will realize that there is one pillar missing. That is the human exposure via the environment. That's not in either in ProScaleE nor in ProScaleH. And that will be a potential for further development of ProScale, because that would be the last pillar to make it complete. Next slide. So this is already at the end of my introduction, to give you a little bit the overview where we are coming from and what is the intention of ProScaleE. As I said, ProScale was there to establish an easy-to-use method to calculate the human health toxicity potentials. Now, ProScaleE should be the same for aggregated ecotoxicity potential. So in principle, every raw material in a process will be assessed how much ecotoxicity potential it will create during the life cycle of that product. This will take into account all exposure to environment and all ecotoxicity potential and exposure potential of a substance by a scoring model. And the scoring model will be derived from reach-based data. You will get the explanation of all these details in the coming presentations. It's a performance-based indicator that can be used and also applied within LCAs, considering all the outputs of potential environmental impacts. And it's throughout the life cycle, from the process starting substance to the end. It will identify also the hotspots when it comes to ecotoxicological risks, and you could also reduce environmental hazards and exposures in a life cycle by identifying these hotspots. As I said, the future will require us much more sustainability assessments, be it ESPR or construction product regulation and many other regulations to come, including the CSS in general. And here, ProScale and ProScaleE is an excellent tool to meet all these forthcoming, but also the existing requirements for safe and sustainable use of chemistry, and also the increasing demand for information. ProScaleE will then take into account the ecotoxicological aspects. ProScale was for the human health aspects. With that one, I am at the end of my introductory presentation, and if there are any questions, we can discuss them now.
Thank you, Martin. Yeah, thank you, Martin. We'll address the questions at the end of the first session, but thank you very much for reminding us of the fundamental motivations and logic of ProScale. And now we go to the heart of the matter and asking Tomas to explain us how to add E to ProScale, how to account for ecotoxicity. Tomas Rydberg is a senior researcher at the IVL Swedish Environmental Research Institute. He currently serves as the technical secretary in the ProScale consortium, in addition to being a number of things, among them activity leader for SSbD case studies in the EU-wide PARC project and senior advisor in the Swedish MISTRA SafeChem research program. Tomas, the floor is yours.
Thank you so much, Geneviève. So let's dive into the topic directly here. So we have seen already some of the fundamental drivers behind ProScale, so I won't read them out again, but you can see them here if you read them briefly. So just want to little bit explain how the discussion was when we wanted to develop the ProScaleE approach and method, and we already in the original guidance for ProScale that came out in connection with the launch in 2017 had a statement about the let's say prospect of doing an ecotoxicity related method that would cover the same or be very similar, let's say, or analogous to ProScale at the time. And as Martin explained here, it is sometimes fair to talk about ProScale H and now ProScaleE, but for the consistency today, ProScale will refer to the human toxicity approach only, and ProScaleE will refer to the new method on ecotoxicity, obviously. If you want to dive into the guideline that is there for ProScale, you can find it under tools on the website of ProScale, and feel free to surf there later on. During the launch conference in October 2017, we also had a small discussion group, task force or working group discussing in a breakout session if and how the principles of ecotoxicity could be applied, and if it made sense to apply them in the similar way that the human toxicity is addressed. Now, because there were some years in between, we carried out a little user needs survey in the context of the Mistral SafeChem program, actually, and you can find the full report under deliverables in the Mistral SafeChem website if you're interested, but I will give you a bit of the highlights here, what the recommendations were. So falling back more or less to the original idea that we wanted to have, or the users wanted to have, a very similar approach as for ProScale, and it was very important to have a feasibility and practicability, so easy to use basically. It must cover the intrinsic ecotoxicity of substances, of course, but there needs also to be some element or factor or parameter that takes into account the exposure. So something about the fate of a chemical from this point of emission to the point of effect in the environment, basically. So having said that, you've seen this before, but what are the actual parameters that we work with in ProScale, and what would be the corresponding parameters for ProScaleE? Well, as Martin already has pointed out, the ProScale method is based on ecotox for the exposure. We have, to a large extent, based our person-hour factor on documents available here shortly explained as BREF, so the best available technology reference documents, because they contain in many cases an overview of the sector, so it makes sense to look there. We've also looked into more details to see if there are big differences between different, let's say, individual companies and large size, small size companies, etc. And hazard factor, which is based on H phrases in OEL and DNL, and you will see more about that later. Another thing that was important in the background for coming up with ProScaleE was to look at the, you can say, the structure of these different factors, if we were to be able to find a similar approach for ProScaleE. So the ProScale, and how, just for clarity, I wrote that here we mean for direct human exposure, builds on the ecotox TRA, which actually estimates or provides an estimate of the concentration in the work environment, predominantly for work environment purposes, based on the existence or occurrence of a chemical in a specific production environment. So that's a relatively specific thing. And then we have added the person-hour factor, which basically converts the concentration into a dose to the relevant persons. And then, of course, the hazard factor will describe the effect or the impact potential. Looking at typically other LCIA methods, life cycle impact assessment methods, and for toxicity purposes, as you heard Martin explain, for example, UseTox estimates the effect on humans via environmental exposure. But in all aspects of life cycle impact assessment approaches, there is a life cycle inventory emission that is coming from, let's say, life cycle inventory data that can of course be produced in various ways, but typically you start with the release somewhere, or the emission as it's called there, and then you calculate a fate factor and including other factors to arrive at an effect ultimately. Typically referred to as a characterization factor, and if you're an LCA practitioner you obviously know all this, but maybe there are some of you that are not exactly LCA practitioners but rather have a risk assessment background, so it might be a bit useful to you to have an understanding on the surface of these concepts. So the release factor needs to be added if you want to have something about, well, that has the same starting point for ecotoxicity assessment as we do for ProScale. And you can understand maybe from this slide that the different factors are more or less, how can you say, exchangeable with other approaches. So you can use these, or you can potentially think of having, let's say, the release factor can be estimated in different ways, obviously. So we'll get back to that later on a little bit. So just to dig into what is the specific context or the specific content of the exposure concentration factor in isotope TRA, and this is one very limited example, but just for explaining the principles. It's based on a recognition of around 30 process categories. So all processes essentially happening in chemical industry can be better or worse, but at least somehow included or assigned to a certain process category, standardized. And I just listed 4 of them here. And then for liquids and gaseous compounds, commonly referred to as fluids in isotope TRA, they are the most important determining factor for the estimation of exposure is the vapor pressure of a substance. And there isotope TRA uses what you can refer to as a exposure banding approach. So there are 4 different levels of fugacity level, as it's called here, depending on the vapor pressure of a substance. So essentially what you get out of isotope TRA is a discrete number representing the estimated exposure to a substance in a specific setting of a process. These are the initial estimates, and then these can be modified by various exposure modifiers, including protective equipment and so on. But this is just for the principle, of course. So as I already indicated in the previous slide, the numbers coming out of isotope TRA contain both the prediction of an emission from a process and also the air exchange, because that obviously represents how much concentration you receive of a substance in a specific surrounding environment. And these are not necessarily very directly translatable to an environmental exposure context, but of course the emission rate prediction can be estimated one way or the other. So we needed to come up with a way of having a useful and meaningful way of estimating the emission rate from a process. Potentially we were discussing to, let's say, calculate backwards from the numbers in isotope TRA. But the air exchange rate here in the isotope TRA for human represents sort of a fate factor, you can say, because it's sort of a dilution factor, and the most similar approach in an environmental context would be some kind of fate model. So we needed to come up with a model about to also establish the fate of substances, or an approach to do that. Similar discussion about the hazard factor we can take here. I won't say much, but we can say that the hazard factor banding in ProScale for human is based, of course, on the H phrases for human toxicity. So we wanted to come up with something similar for environmental toxicology. So it would be based on the H400 phrases somehow. But there is also another factor that we work with in ProScale, and that's, let's say, a modifier based on the, or that will represent the potency. of a substance. So within each hazard class, a substance can of course cause the harm with less or higher concentration. So we wanted to have some parameter to take that into consideration for ProScale. And so we needed, or we have discussed how can we achieve something similar on ProScaleE. So what would be a suitable analog to ecotoxicity to the OEL or DNL concept that's used in the ProScale? And colleagues here will talk more about these details later on. Now, we also were considering what are the, or how many factors or how few factors can we actually reduce the model to, but still have a reasonable scientific precision, if you like. It's very difficult to validate these kind of ecotoxicity models in reality. So most of the time you rely on various cross comparisons across models and see how well they align or not. And here I've been involved in this kind of research for some years, and already about 20 years ago, there was an analysis carried out in a project called OmniTox. But anyway, the outcome there was basically when looking at different models that were trying to model the ecotoxicity and also human toxicity. But anyway, here we talk about ecotoxicity. The most important factors are two factors. One that is a metric of ecotoxicity, and for the fate, the most important one was some kind of metric of persistence or degradation. In some cases, depending on how, let's say, much you want to fine-tune the model, the Henry's constant that determines the distribution between water and air for a substance might be relevant, but and sometimes here could be read as for certain types of chemicals. There is a reference to the paper here if you want to dig into that, obviously. But with this background, we said, okay, so let's see if we can develop a method that builds on the same structure. We have an environmental release factor, we want to use a degradation factor, and we have a hazard factor. So we more or less align with the findings of this paper where the simplified model was discussed. And having said that, I'm soon to leave over to my next speaker here, but a couple of summary points or takeaways is that we were able to build a method, ProScaleE, building on the experience that we have had with ProScale for human toxicity. And we are quite confident that we will be able to fine-tune it if needed to be even more precise in the future. And there will be more details coming in the following presentations. Thank you very much, and back to you, Geneviève.
Thank you, Thomas. We'll now dig a little bit further into the details of the method, and Pearl Nemeth will detail the hazard scoring model that has been used to develop ProScaleE. Pearl is an expert consultant on EU REACH and chemical regulation at Anthesis Caleb. She has over 15 years of regulatory experience and has a particular interest in the interface between chemical regulation and circular economy, LCA and emerging product-related legislation, just at the heart of our preoccupations today with ProScale. Pearl, up to you.
Thank you very much, Geneviève. Welcome everyone, and very good morning to you. I'm going to provide you with a short introduction on how we define the hazard scoring model for the ProScaleE methodology. First of all, I'm going to talk a little bit about the starting points and aspirations of how we wanted to, what we aim for with our development work. Then touch on a couple of the challenges that we faced in the last month or even a year, I think. And finally, I will introduce the key results. So first of all, I think Thomas already mentioned that we really wanted to make the ProScaleE hazard factors as similar to the ProScale human health model as it makes sense. So as Martin and Thomas already introduced, in the human health side, the ProScale methodology builds on hazard phrases from the GHS, so the globally harmonized system, and its implementation into the EU, the CLP regulation. That the hazard phrases reflect the severity of the chemicals, and these define the hazard bands. And as a fine-tuning, there is a further scaling between in these bands or within these bands based on the potency of the chemicals, based on their DINAs and OEAs. A second aim was, as I said, to build on the GHS and CLP system. So I'm sure everyone is familiar with the traditional acute and chronic aquatic toxicity hazard phrases, but we had to also consider, or we really wanted to consider, the latest revision of the CLP regulation last year that introduced the new environmental hazard classes. That is the endocrine disruptors for the environment, the PBTs, VPVBs, so the persistent bioaccumulative and toxic substances, and the PMTs, which is the persistent mobile and toxic substances. The other aspect of the CLP regulation that we looked in detail is the M factor. This is like a multiplication factor or a safety net for hazardous chemicals when they are mixed within mixtures. And it is, as you can see on the right-hand side of the slide, the M factors are determined based on the EC50 value. So that is the aquatic toxicity study measurement. This is coming from the aquatic toxicity studies. So you can see here that the M factors are basically an illustration or the measurement of the potency of the substances. And finally, next slide, please, Thomas. The other aspiration we had is to really build on the SVHC approach. So this is the substance of very high concern. This is coming from REACH, from the REACH regulation. It's basically the determination of the substances with the highest concern based on the hazard. And also in the broader sense, the SSbD approach, which was also already touched upon in the previous presentations. So you can see on this slide the environmental hazard classes that within the SSbD are the highest concern, which in fact chemicals with these hazard determinations are not considered safe and sustainable chemicals or materials. So this is in the very top, the PBT, PMT, and endocrine disruptor substances. The next one is chronic toxicity and endocrine disruptor category 2s. These are still, these substances still need to be eliminated. And the last one is the acute toxicity, which still, these substances are still flagged for substitution. So we wanted to build on this and align our hazard factors with this sort of hierarchy of hazards, but I think you will see in a couple of minutes how much we ended up being in complete alignment or not. So just to show you, introduce you a couple of challenges. So as I said, it's setting up a hierarchy of which hazard should be the highest concern is a bit of comparing apples and pears. So we had quite a lot of heated discussions about it, with considering the aspirations that I just introduced to you. And also, I mentioned that the new environmental hazard classes introduced by the latest CLP revision actually bring in persistency into the hazard classification of the substance, and that produced us with some sort of challenges, because it's obviously an overlap with environmental fate, which my colleague Thanos will introduce to you in the next presentation. So we had to be really conscious of these persistent categories, not to sort of double punish them first under the hazard factors and then again in the environmental fate. And next, another challenge that I wanted to touch upon is just the potency, how to implement it into the environmental side. You have seen it before, that in the human health side, the potency was based on the DNAs and OEAs was used to determine the sort of internal scaling in between the hazard bands. We looked at the M factors coming from the CLP regulation, but also we discussed whether PNACs, so the analog of DNAs, should be used for scaling the substances. You will see in a couple of minutes how we implemented this into the system. It's not quite the same as the logic the ProScale Human Health followed. And finally, data lacking, and I have to say that this is kind of ongoing work. Especially because, so what I mean by data lacking is how to define hazard scores for substances with missing data, and we wanted to make, we would like to make a differentiation between chemicals which don't have the basic acute and chronic toxicity data, which ideally, especially if they went through the REACH registration regime, these data should be available, but with the new hazard classes introduced only last year in CLP, that data on PBT, PMT, and endocrine disruptor properties is only still in development. So there need to be some sort of differentiation. So then finally, the key results. You can see that the hazard scores are quite similar to what we have in ProScale Human Health. However, we don't have two separate tables. We actually ended up incorporating the M factors, so the consideration of the potency of substances within the same table. You can see that we very much built on the SVHC and SSBD approach as we wanted to, but we also sort of deviated it because we thought there was quite a lot of back and forth, and tried to make sure that whilst our approach is aligned as possible with the European policies such as SSBD and SVHC considerations, we also feel that it's scientifically robust and everyone can wholeheartedly support the ranking of these chemicals. So you can see that, for example, chronic toxic substances with the highest M factors would go in the highest band rather than the ones below how SSBD would suggest it. So you can see on the right hand side in the colorful boxes some of the illustration how it is aligned or deviates from the SSBD ranking. So I think I give you back the floor, Geneviève, for the next presentation.
Thank you. Okay. Thank you very much, Pearl. We now have Athanasios Gkrillas from Dow Chemical, who will present us the release and environmental fate factors. Thanos is the lead risk assessor supporting businesses on surfactants, coatings, and construction chemicals. Additionally, he performs human and environmental risk assessments for REACH registrations and has been involved in the safety part of the SSBD framework. Thanos, thank you.
Thank you, Geneviève. Can we go to the second? Yes, thank you. So besides the hazard, we wanted to account also for biodegradation. There are many definitions in the literature. One I selected is when items including natural and man-made chemicals break down into smaller parts by natural processes like bacteria, fungi, or other biological means. In general, microbial transformation is the main mechanism by which an organic chemical can be completely mineralized. Can we go to the next slide? Yes, thank you. Now, how to include biodegradation in ProScaleE? We decided that the hazard score of non-biodegradable or persistent chemicals should remain as is, so the hazard score is multiplied by a degradation factor of 1. But for inherently biodegradable and readily biodegradable chemicals, the score can be reduced by a 10-fold and 100-fold respectively. This 10-fold difference between each biodegradation rate is also consistent with the elimination rates mentioned in Simple Treat 3.1 in acetyl-CoA environment and in the user background document. Can we go to the next slide, please? And here are 3 examples of 3 chemicals with different hazard scores. And we see how their hazard score can be further reduced when applying the biodegradation factor. The score of nonanol, for example, becomes 1 from 100. The score of PPA becomes 1,000 from 100,000. And the score of MIT remains unchanged at 10,000 since it's not biodegradable and is multiplied by the degradation factor of 1. Can we go to the next slide, please? As a next step on how to introduce environmental releases, we are thinking to use the environmental risk categories, or ERCs, as a starting point. ERCs are also used in REACH as conservative release factors for the different use exposure scenarios. And they can be found at the ECA guidance R16. Can we go to the next slide, please? So here is an example. So if we select the manufacturing use, or ERC1, and its respective release factors, which are 6% for water, 5% for air, and 0.01% for soil, we see how the ProScaleE hazard score can be further refined for each environmental compartment by introducing these environmental release factors. Can we go to the next slide, please? In the next version of the tool, we are also thinking to include physical information like water solubility, vapor pressure, partition coefficients, parameters that are important for estimating exposure, for example. Additionally, the user could refine the releases even further by including specific environmental scenarios, or SPECs, from the different trade associations that can be found at the ECA use library. And how it could look like ProScaleE as a tier 2 tool, maybe in the future. By adding also physical information at the manufacturing scenario of, let's say, 1 kilogram per day that was mentioned before, the exposure concentration factor can be included by taking into account the respective predicted environmental concentrations. We see how the final score can be further reduced or refined from the initial hazard score. And for the various exposure use scenarios, if the user decides to use SPECs, or even if they have specific site-specific information, then the score will be even more precise and closer to real life. Thank you a lot. That's all from me. Back the floor to you.
Thank you very much, Thanos. We now have some time for taking questions. And I noticed that in the chat there were a couple of questions. One concerning the fact that PEF is prescribing use tox to assess human and ecotoxicity today, and questions about expectations that the PEF guidelines could include ProScale H and E in the future. And then there's another one about the hazard factor in also the ProScale H methods, the fact that the data is based on information from SDS, but there's a question about concentration limits in SDS, etc. Peter Zaling, who is a colleague of Martin Klatt, has joined us, and he will answer those questions. So Peter, the floor is yours. Thank you.
Yeah, thanks, Geneviève, and hello, good morning from my side. Peter Saling is speaking. Yeah, on the PEF element, we work since a longer time that we want to show the introduction of ProScale to the PEF methodology. So we introduced it several times to the technical advisory board, where I'm also a member of. And we also put it in a position paper of CEFIC. So we try to put it in different ways that it will be accepted at least as a complementary approach in PEF. So far, it was not accepted there, but we still try to push that in that direction. And we also try to put it again on the agenda of the PEF tab. But yeah, it's sometimes not so easy if you want to change things there. And so probably I am a little bit disappointed there, because we could show that ProScale is really a useful and applicable tool. And I showed it also on the CTEC conference this year, some weeks ago. So we really have something good in hand, and we should show that in PEF that we can implement it. So that's a situation there now, and I hope that we are succeeding to bring it more forward. On the other question, it was on the SDS and minimum concentration or maximum concentration. So for sure, we use in main of the elements, we use the safety data sheet, but at the end, you also can go to the ECHA homepage where you can have additional information. So if you have a molecule that can, or a compound that is probably not accurately described in the SDS, because there are some requirements that you have to report on, then you always can go to the ECHA homepage and can cross-check that. But that's a specific question probably we need to handle again, also to put it in the guideline, what to do there. And I think in the ProScale guideline, we already put it in, and we have some solutions for that.
Okay, thank you.
It's okay, yeah.
Thank you, Peter. We have another question directed to Thomas. Has anyone already tried applying the ProScaleE methods for nanomaterials? And if yes, have that person modified anything in the methods? Thomas, can you answer that, please?
Yes, I will try to do so. To my knowledge, it hasn't been tested until now. We are currently, since the beginning of this year, involved in a new research project, CHEMAT Sustain, that addresses specifically nano materials. So there it will definitely be tested relatively broadly, I would say. Actually, one of the challenges there already is that it's unclear how the nanomaterials should be classified in terms of the hazard classification. So that's also, for other purposes, an important aspect of that project. So that is something that we hope will come out of this project, actually. In addition, we are going to look in depth on the aspect of exposure coming from particulate products or nanomaterials in that case, but also I think we will broaden it to more general particulate matter, because that's an issue that we often understand from test pilots or practitioners of ProScale, that it's a bit difficult to grasp maybe. But that essentially boils down to the way that has been defined in ECOTOX TRR. But we're working on that, and we hope to come up with a solution within the next month or a year, maybe. Thank you.
Thank you, Thomas. Thank you, Thomas. We have another question relating to the use descriptor system in ProScale ERCs. Can an SME use that type of descriptor system without guidance? So, Peter, could you please answer that? Thank you.
Yeah, so I will give it a try. So for sure, SME, so I don't see really a big difference on bigger companies or SME. So there's everything there. Without guidance, I would say if you read the description of the ERCs or ERCs, then you should be able to use them. But we don't have a final methodology description so far for ProScaleE. We can put it in the, let's say, in the final description as we have done it for ProScale as well. And so, yeah, to answer that, I would say without guidance, probably difficult, but with the guidance which we will provide should be no problem.
Okay. Yeah. Thank you, Peter. We have a couple of other questions that are more relating to the interpretation of the results of ProScale. Thomas, may I suggest that you answer these two?
Yes, can you read them out maybe, because I have the presentation maybe in front of me, so I don't know which questions you refer to, unfortunately.
Right. First question, are the resulting indicators from ProScaleE to be interpreted in a comparative way, by e.g. substance X is better than substance Y, or absolute, substance X is or is not SSbD, or both?
I would say no, the results should be treated or seen as comparative results. But as Pearl showed in her presentation, the scoring system is more or less, or at least to a certain extent and quite much actually, aligned with the levels in SSbD. Now the SSbD leveling of substances is not taking into account the potency. So, and that, as you saw, we have introduced by the use of the M factor. So, and that is because we wanted to, and the main difference here is that actually when you apply this kind of impact assessment factors and put it into a life cycle assessment context, you basically take away the absoluteness and introduce the relativeness. Then, of course, there are these developments going on trying to relate the outcome of an LCA to planetary boundaries or other types of references that, and of course, in the case of planetary boundaries, it would indicate the kind of absoluteness. But the scores themselves coming from a life cycle assessment are not absolute. They are relative. And for sure, you can use it to compare between products, but definitely also within the life cycles. And we will see an example of that later on, when Rosella shows an example that we have applied. So I think, yeah, that is how much I understand the question and what to answer to it. Yes.
Thank you, Thomas. The second question, I think, will better be addressed in the second part of the webinar, because it relates to the integration of ProScale into LCA tools and LCA databases. So we save it for the second part of the meeting. Okay.
Okay.
Any other question on this first part? Otherwise, I think we can go to the second part of this webinar, which will go deeper into some of the prospects, a case study example, as we mentioned, and the integration of ProScale in LCA software and the SSbD toolbox. Okay. We now go into the question of how to fill data gaps, in ProScale and ProScaleE. And for that purpose, we have Ziye Zheng addressing us right now. Ziye works in IVL as an expert in computational modeling. His research focus is machine learning prediction of chemical hazards. Ziye, the floor is yours.
Thank you. Yes, I'm going to talk about how to fill in the data gaps for the chemical hazard. So as we already heard in the first part of the seminar, that ProScale and ProScaleE uses edge phrases from the CLP regulation to assessment of chemical hazard. So since we have so many chemicals in the market right now, it is very important that we have a harmonized way to communicate chemical hazards, and the regulations with harmonized or standardized hazard scoring system like the United Nations GHS system and following up EU CLP system are very useful for this purpose. If you can go to the next slide. Yes, but the main challenge for using regulations like CLP is that sometimes we are facing a lot of data gaps. For example, if you look into the EU REACH registration dossiers, there are around 30,000 entries in the dossier. And if you remove, because some chemicals have multiple entries, so if you remove this replicates, and if you remove those chemicals without known structures, and if you remove all the mixtures, you can only find the data for around 16,000 chemicals. And if you want to look into the CLP annex for harmonized classification and labeling, there's only record for 4,372 chemicals for the newest database. And sometimes when people look into this database, they're kind of misunderstanding the harmonized classification in CLP annex, because the harmonized classification are only for the most critical endpoints. So sometimes when you see a chemical, you see the H phrases labels, you know that this is toxic. But if you doesn't see the labels, it does not necessarily mean that this chemical is not toxic for this endpoint. But sometimes it's just a data gap that doesn't have sufficient data to prove it right now. So in order to face these challenges in the Mistral SafeChem project, we are trying to develop like a reliable prediction tools to fill in the data gaps so that we can have a better understanding of the H phrases of different chemicals, especially those emerging chemicals. Yes. So to build a machine learning model to predict a chemical hazard, there are several steps. The first step is, of course, we need to collect known data that can be used to train the models. And then we use different methods to describe these chemicals and find the link between chemical and chemical structure with their toxicity properties with different machine learning algorithms. And then we need to calibrate prediction uncertainties and validate the model performance. And the last step is that we try to put all the models under like a friendly user interface, so people with non-programming background can still use the models. Yeah, so for the data retrieval step, we try to retrieve the data directly from the REACH registration dossiers. The reason for doing that is because, first of all, we want our model to follow the standards of EU regulations. So all this data in REACH registration dossiers follows either REACH or CLP regulation. Secondly, it is because, like, for many endpoints, especially the ecotoxicity endpoints, sometimes you cannot find a lot of data in other like published literatures. But actually in REACH dossier, there are a lot of data that machine learning modelers haven't tried to build models before. And yeah, after retrieving all this data, then because in REACH you can find chemical names and chemical class number, EC number, but there's no structural information. So with the retrieved data, we try to use PubChem and CIR from US FDA to retrieve chemical structures or SMILES. And then the retrieving results is like the table on your right-hand side that for each of the endpoints, you will have at least a few thousand chemicals for each of the toxicity endpoint. And if you look in the rich dossier, another good thing is that people submitted the data to rich dossier. They make it very clear if it's negative, like if they say data conclusive but not sufficient for classification, basically that this chemical is non-hazardous dose for this particular endpoint, or they say it's very clear that the data is still missing or like not conclusive. So we treat it as a data gap and remove it from the training set. Yes. So in the Mistral Significant project, with the retrieved data from rich dossier, we built two different sets of models. One model is developed by Professor Ulf Norinder from Stockholm University. He used various methods to do smart embedding and molecular fingerprint to describe chemical structures, and used random forest to build models for each of these methods, and then build a big consensus models with a combination of all his approaches. Another approach was developed by me. For the last 2 years, I was a postdoc in Sativa. There, I used a more newer technology that directly used the image of chemical 2D structures as graphical input into a graphical neural network to build deep learning models. So in order to assure that the model have good performance, the first thing we do is, like, for each of the endpoint, we separate at least 10% of the data to validate the model performance. And in order to ensure the uncertainty level of each single predictions, we use a mathematical framework called conformal prediction that can be used to calibrate the prediction uncertainties. Next slide. Yes, so as you can see, the model has quite good performance. For each of the endpoint, both methods have accuracy higher than 75%. If you look into machine learning models for toxicity prediction, actually this is already a very high prediction accuracy. And considering the data uncertainty in the training data, we think that improving it furthermore might need improvement in the training data first. And if we try to say that let's force the model to give at least 80% prediction certainty level, you can see that when we test the models in the general chemical space, at least 90% of the chemicals can be predicted with at least 80% confidence. And for the rest 10%, the model will tell you that, like, we cannot give you such a high level of certainty, or if the compound is just outside of the modeling domain. So you will know, like, which models that which molecules cannot be predicted with this high certainty. Yes, and another advantage of using the graphical neural network model is that the algorithm tell you what's the hotspot in the structure. So as you can see here as a example, that the graphical attention network tell you, like marked in green here in the structures, that's the hotspot for different toxicity properties. Yes. So what's going on right now in Mistral Significant project is that we are trying to put these development models under a user-friendly interface so people can easily use it. I have to point out that the version you are seeing right now on the screen, it already contains several models, but that's not the models I mentioned today. That's the models we trained with literature data for other human toxicity endpoints, including endocrine disruptions, CMR, skin sensitization, and also chemical persistence and bioaccumulation. And the model I present to you today, the H-phrases models, will be added to this software later this year. Yes, so some short conclusion for my presentation today, that we have developed good performance machine learning models to provide reliable predictions for H-phrases for all human and ecotoxicity endpoints in the therapy regulation. And these models can be used to fill in data gaps for ProScale and ProScaleE. And next slide. Yes, so for my project, I would like to acknowledge the financial support from Mistra, of the Mistra second project, and Sativa for my postdoc research. And we receive a lot of support from our other partners, including Stockholm University, Research Institute of Sweden, IVL, ChemSec, and PestHop. They give us a lot of suggestions about the ECHA database. And we would like to especially acknowledge ECHA that allow us to do the data mining on their website. And thank you for listening to my presentation today.
Thank you, Ziye. Thank you, Ziye. That was fascinating, deep dive into the possibilities of data mining and its implementation in terms of predictions. Thank you very much. Well, we now come to a part that you've all been waiting for. How does it work in practice? Rosella Telaretti Leggieri, who's a researcher holding a PhD in chemical science and engineering, works at IVL, and she focuses on the application and development of methods for environmental and human health impact assessment of chemicals and materials. And she's taken the time to go through the depth of the case study. Rosella, we're all ears.
Thank you. Thank you, Geneviève, and good morning to the audience. I will walk you through a case study that we selected to exemplify the application of ProScaleE at this stage. And the motivation behind the choice of this case study is that in another project that IVL participates in, the European project PARC, the Partnership for the Risk Assessment of Chemicals, ProScale for Human Tox was selected as one of the tools tested for conducting an assessment within the Safe and Sustainable by Design framework. So we decided to start testing the new ProScaleE alongside the ProScaleH assessment on this system. And we modeled a cradle-to-gate product system where the gate is polycarbonate production. Polycarbonate is produced in this system from bisphenol A, BPA, and phosgene using dichloromethane as a solvent. And this is a tier 1 assessment where energy requirements and transport are not modeled at this stage. All unit processes in the system were assessed with ProScale and ProScaleE. So the production of polycarbonate, the production of the starting materials for making polycarbonate, and then all the way up to the fossil raw materials production until crude oil extraction and other processes. The results are to be taken as preliminary, since this study was conducted with the aim of testing ProScaleE and complementing ProScaleH results with ProScaleE results. So modeling choices and scores are not definitive, and the model is rather simplified at this stage. But we can go to the next slide. And first of all, we can recap on what kind of results are provided by the already established ProScaleH method. So in ProScaleH, we get a ProScale unit score, PSU, which represents the human toxicity potential of a unit process. So we can compare the impact of each unit process in the system. Here, for inhalation exposure in the graph shown in this slide. And here, most relevant processes are color-coded so that one can compare easily. And we can see that the processes involving the extraction and refining of fossil raw materials have very large impact on human health, as well as a few other processes that also stand out. And yes, so ProScale also provides toxicity potential via dermal exposure, which we can see in the next slide, where the pattern slightly changes for dermal exposure. And again, one can compare the impact of these different processes on human health, and in this case, via dermal exposure. But now we can move to the next slide. And before we dive into ProScaleE results for this system, I will briefly explain how I collected the data I used for the calculations. And both for the hazard factor and the degradation factor, I mostly used data from REACH dossiers. And in a few cases, data gaps were filled with prediction tools that were run by my colleague Ziye. We also decided to test the new hazard classes that ECHA started implementing last year in 2023, and specifically, for instance, endocrine disruptors. As for the environmental release factor, I used mostly environmental release categories ERCs from ECHA, which are very conservative estimations of release of substances from each process, except for solvents. For solvents, I used for solvents used in the processes, I used specific ERCs that were developed by the European Solvents Industry Group. And finally, allocation was applied to all the processes where more than one valuable product is produced, and it was conducted on mass basis. Next slide, please. So here in this slide, I am reporting the characterization factors for some of the chemicals involved in the system. So these characterization factors in the column to the right, all to the right, are calculated by multiplying the hazard factor by the degradation factor for each of the chemicals. And for instance, we can see that BPA has the highest value of characterization factor that we got in this system model due to its high hazard factor, as BPA has been classified as endocrine disruptor category 1. And now we move to the results. Please, next slide. Yes, so according to the ERCs, we modeled emissions to air, water, and soil. Here we see emissions to air. So we see the ecotoxicity potential of all the emissions modeled coming from all the processes. So emissions of crude oil from various unit processes appear to be a hotspot here, and the impact of BPA and dichloromethane emissions are also relevant. One can also observe how the results are affected by the selected ERC. So if we look at DCM emissions from the production of polycarbonate, where DCM is used as a solvent, the specific ERC used assigns emissions to air, depending on the volatility of the solvent, and assigns 0 emissions to water and soil. So if we move to the next slide, we see that here we have no emission of DCM from polycarbonate production, which was the red bar to the left. Exactly, thank you. Yes, and finally, we can show also the results of emissions to soil, where the emissions are get a score roughly 2 orders of magnitude smaller than for air and water, according to how the emissions are modeled with the ERCs. And the trend is slightly different, again, due to the modeling. And so in conclusion, next slide, please. In conclusion, with this example, we start showing how the new ProScaleE model can translate rich data on hazard and fate into characterization factors. And ERCs and SPERCs can be used for this screening assessment but also the assessment can be refined with, for instance, first-hand data on emissions. And finally, this method involves quite simple calculations and has the potential to allow the user to identify ecotoxicity hotspots. Thank you.
Thank you very much, Rosella. Thank you very much, Rosella. Very interesting first-hand use of the ProScaleE method. As you saw from the various presentations, there's still a lot of work going on around ProScale and ProScaleE and their development. And Hanna Holmquist will give us now an insight into the current and upcoming research activities. Hanna is an ecotoxicologist and environmental systems analyst at IVL. She holds a PhD in environmental systems analysis, and she's currently leading several activities within IVL, advancing the science and application of life cycle-based tools for chemicals management. Please, Hanna.
Thank you. Thank you for that kind introduction. So I will show you some slides on current and upcoming research activities in relation to the ProScaleE development. And I would like to start with one of our main research programs in relation to safety and sustainability assessment. It's a Mr. SafeChem program. Ziye has mentioned it already in his presentation. For the past 4.5 years, we've run Mr. SafeChem in phase 1, and we are very pleased to know that we will continue for additionally 4 years. And it's a large program addressing many relevant aspects, and we have a fairly large number of research tasks related to ProScale and ProScaleE developments. And here I would like to highlight that we will explicitly employ an early career researcher or a postdoc, if you like, to work dedicated on advancements related to ProScale. But I have another slide on that in a little bit. Other projects ongoing that contribute to the further development of ProScaleE is the Calimero project on environmental performance and sustainability of bio-based industrial processes. The ChemMat Sustain project, we had a question on that earlier. It has a focus on nanomaterials. Thomas mentioned it. We have these 2 projects are ongoing, and then we have a new project starting very soon by Sustect. It's about textile value chain and the sustainability of these and their assessment. And then a new project on substitution and chemical alternatives assessment to achieve safety and sustainability. So I will go a bit into detail in a few examples. So next slide, please. Ziye already mentioned his work on the machine learning tools, where we put a machine to train on existing data, on substance properties or H-traces, if you like, to give us predictions of for substances that are not yet tested. This could, of course, be relevant for ProScale and ProScaleE, in particular if we have an innovation context where we might want to include chemicals that are not yet on the market and hence not yet assessed. So within Mr. SafeChem, we have explored the use of this battery of in silico tools that Ziye showed with the user interface. How can we go through the hazard bands and see what could an initial H-trace be or a preliminary H-trace? We are, of course, in parallel also using these new tools on the H-trace predictions. So we are looking into how can these be used, what guidance do we need as LCA practitioners to use the tools, and how do we propagate uncertainties in a correct way. And we expect to work on this also in phase 2 of Mr. SafeChem. Next slide, please. So it continues in phase 2. The vision of Mr. SafeChem is let's see here, is to enable and promote the expansion of a safe, sustainable and green chemistry. And of course, ProScale becomes one of many important tools to achieve the process development, the chemistry development and the assessments needed. I selected here a few research tasks directly related to ProScale development. So this early career researcher will have 4 focused tasks. It will be on ProScaleE specifically, to take it from the conceptual model to case study implementation together with our industry partners in the program. So similar to what Rosella has done, but being able to dig a bit deeper and to build additional cases. We will also look into the further expansion of the scope of the toxicity potential approach. So looking into service life exposures and use phase exposures, as well as the humans via the environment exposures, as Martin explained earlier in this webinar. And we will continue work on this early design decision making and how can we incorporate in silico tools in the assessment in a sound way. We connect all this, of course, to the safe and sustainable by design assessment framework, both to provide operational tools, but also to provide feedback to the GRC on their further development of the framework. Next slide, please. So not only Mr. SafeChem, of course, but other projects are ongoing, about to start within short. And of course, we are networking and engaging to apply for additional research funds as relevant calls come up. So Mr. SafeChem, but also other projects are working on this improved operationalization of the use phase exposures. We have the conceptualization and compilation of data for the dustiness parameter that has shown to be tricky in some case applications so far. And here we will have a focus on nanomaterials as well. We will have the implementation of the ProScaleE in the web tool to increase the ease of use, and also the advancement of the current web tool on the ProScale on the human toxicity side. And of course, we are continuously building on the database with default process data and characterization factors to simplify the build of new assessments by use of ProScale, not having to start from scratch. And we're trying to look into how to integrate the in silico tools in the user applications. So that was it from me. Thank you very much.
Thank you, Hanna. We now addressing the last presentation of today's webinar, and it's about the integration of ProScale and ProScaleE in LCA software and SSbD toolbox. Tomas?
Yes, hello again. I hope you can hear me well, and this will partly be a bit more technical maybe, but I will try to keep it on a relatively generic level still, because well, I'm not so much of the technician myself on these aspects, but it's more about what we are planning to do, I think you can say. Some of you in the audience have already come across or tried out or using the web tool, so you know what it looks like for now. It's for those of you who haven't, you should be aware that it is there, but it has currently limited functionality, and it's very much a standalone tool, and it works well to let's say build an assessment of one individual process. Currently, you enter basically the bill of material in a process, inputs and outputs, and potentially if there are materials that are intermediates within the process, they should also be addressed, obviously. And then you get the score out, provided that you have, of course, the hazards classification available for the substance. If you don't have it, you need to come up with something there. For example, using something along the lines of what Ziye presented, but it's not been integrated in the tool for now. So what we will do here is that we'll actually start right now, and in fact this project Hanna mentioned, the BioSysTex, has a task that's dedicated specifically to the improved implementation or upgrading of the web tool. So we are quite happy that this can start now for real. And of course, one important advancement of the tool will be to actually include ProScaleE, the way we have now designed it to be formulated. So that's really something that we are looking forward to here, and we have secured the competent resources to do this kind of development as well. So that will take on very soon, or in fact next week we will start looking at it. We are also planning, but this is not carved in stone, but I think it's fairly clear that we will have some kind of two-tiered setup. Maybe we can even have more levels, but there will be at some level there will be something that can be freely available to anyone basically after registration. But there will also be some kind of advanced version that will be under some kind of license fee. And one of the points or reasons to have at least one basic level that's freely available is that this is also a requirement for tools to be included in the PARC SSbD toolbox that I will mention a little bit later on. But at least the current thinking is that there will also be the direct access function, so you can use the tool standalone for free at a certain level of detail, but if you want to have a higher, like an expert tool, you will have to buy in on a license. Also, what is very limited in the current tool is the import and export function, or actually you can say there is only an export function. You can export your results in a very simple text or Excel file format. But this part will of course be very much more advanced in the new version, as we want to allow for the integration definitely with the PARC SSbD toolbox, but of course if we have an API, so an application performance interface, we will be able to, or anyone that is interested can of course access it in the same way. So it would not only be the SSbD toolbox per se, but also for the standalone user, or if you want to do a manual import and export of data, I think that's a function that would be very relevant to have in such a tool as well. So just to mention a bit of a challenge that we have in this sense, because, and that applies specifically when we talk about linking or integrating ProScale with regular LCA software. And I mentioned, you've seen almost this slide before, and I mentioned the relatively specific nature of ProScale. There we apply the ecotoxicological, that it starts with the occurrence of a chemical and then provides back a concentration of this chemical. And of course, this is not in conformity with how LCA tools are regularly built, because they are dividing the modeling into a process and systems data modeling in the lifecycle inventory, and then you apply the LCIA characterization factors. So actually we have to do a bit of a tweak there of the ecotoxicological model, and to get sort of an intermediate release rate out of ecotoxicological that we then can combine with the LCIA characterization factor. So that's going to be, well, it's obviously something that we can do and that can be solved, so it's not an unsurmountable thing like that. I just wanted to mention this as a little tweak that we need to work with. It's not the same for ProScaleE, as you have understood from today's presentations. The ProScaleE has a separate module for the release factor. So there it is more, let's say, direct to apply the ProScaleE characterization factor, that we might call it, in fact. So it's quite possible actually that the ProScaleE, although ProScaleE is just a new method and ProScale for human has been around for a while, it might well happen that ProScaleE might come into the tools earlier, because it's much easier from a technical point of view to get it in there. So just before we go into, or when I start talking about the integration or inclusion of ProScale and ProScaleE in the PARC SSbD toolbox, I need to say just a few words about the multitude of tools that are out there and fit into the overall framework of SSbD. So just to explain the graph a little bit, you see on the x-axis here the 5 different steps that are outlined in the SSbD framework by JRC. So step 1 is the hazard performance or hazard properties of the chemical. Step 2 is related to the exposure in the production phase of the chemical. Step 3 is related to the use phase of the chemical in the intended product. And step 4 is the life cycle assessment. So it, let's say, includes all the other impact categories beyond health and safety, which are, so health and safety are in the scope of steps 1, 2, and 3, and life cycle assessment indicators are the scope of step 4. Step 5 is about socioeconomic impacts. We have not looked into specific tools there until now in the work of PARC that I am involved in as well. And then we have also in this graph tried to outline preliminarily where the different tools would be applicable in relation to an innovation stage gauge approach, where 1 is very early stages, ideation stage, and 5 is market launch, more or less. So we've investigated a number of tools. They are illustrated by the segments that are pink in the picture, but specifically we looked at the tools that have been marked by red text. And when I say we, I mean the whole testing group within the PARC SSbD work package. On the IVL part, we have tested, as you heard from Rosella before, the ProScale and ProScaleE now as well. But we also looked into more generically the application of LCA in the context of SSbD. And we've been involved in a few other testing. But anyway, my point here is that there are so many tools that are going to be or trying to be somehow involved in and integrated in the PARC SSbD toolbox. So it's a massive amount of work that's going into this process. And of course, we are then trying to offer our help to the main operator of implementing the SSbD toolbox to actually get the tools in there. So we can't say that we have a, let's say, formal agreement yet to integrate ProScaleE and ProScale into the toolbox, but we have offered that we will help out to do it by means of this project I mentioned, where we have resources to develop the web tool as such. We are planning to start the work very soon indeed, just as soon as we get started ourselves with the development of the web tool. So it will hopefully be part of very early versions of the public version of the SSbD toolbox that is developed on the PARC. And I think that is actually everything I had to say on these issues for now, and thereby I leave it back to you, Geneviève, to maybe take some questions, wrap up, and provide some additional information on that may be interesting for the audience. Thank you for me.
Thank you, Thomas, and we'll start by taking some questions since we have some time, and there's been some very relevant and interesting questions. There's a couple of questions addressed to Ziye. The first one wonders whether the Mistra SafeChem model works also as well for polymers.
Well, I would say that these models are not trained for polymers, but on the other hand, compared to some traditional model which have a limit, for example, like a molecular weight cannot be more than 1,000, these models does not have this kind of limit. But for any kind of machine learning models, you need to have a very clear structured input. So meaning that if you are dealing with a polymer, the first thing you need to do is you need to find one or several representative structure to be input in the model, and the model will tell you if it can make a certain prediction or not, or is it like a higher uncertainty or out of the modeling domain. And these models have been tested here in IVL in several different projects, some with dealing with polymers. And for some polymers, it works quite well, along with the in vitro data we can find. But we are not so sure for all the other polymers. So this is still something remains to be tested.
Okay, thank you, Ziye. There's another one for you, I guess. It's more of a comment, but it's so interesting to see that half of the entries are duplicates. Could there also be a chemical identification or chemical representation issue, or are they confirmed duplicates?
First of all, I think you are talking about registration dossiers. So first of all, they are not all replicates. Some of them are like mixtures or what ECA classify as UVCB, the unknown or variable composition, complex reaction products, or biological materials. These kind of compounds, since it does not have a very clear chemical structure, are removed. And some are removed because that the structure is still confidential, because these data are submitted by chemical industries. Sometimes they have the class number, but does not want to reveal the chemical structure just yet. That's one reason. Another reason is, of course, there are several replicates, and we are confirmed that they are replicates because they have the same class number, chemical names, and all the identifiers. And it's normal because several different companies might submit data to rich dossiers. And interestingly, when we deal with this data, we do find like not very often, but sometimes different entries in rich dossiers conflict a little bit for certain hazard endpoints. And when we train the models, we remove this conflict data. And I think ECA is also aware of the problem and working on it. They are continuous update rich dossier and remove some like too old or too high, too low data quality data from the rich dossiers.
Okay, thank you, Ziye. We have a more general question relating to the ProScale score for emission to air. What does it correspond to? Does ecotox data not apply? Peter, can you answer that, please?
Yes, so for the ecotoxicity, we decided that we stick to the water emissions because there are most of the information and experiments and H phrases linked to. So to air, it's really a low number, and also in the legislation only we focus on the water emissions, and so we decided to stick to the water elements there.
Thank you, Peter. We have one question for a couple of questions for Tomas. One which is, about specifically what would be the changes or additional information required to build into life cycle inventories to be able to apply ProScale LCA in a mainstream way. So when using common LCA databases such as EcoInvent. Do you want me to repeat the question, Tomas?
No.
Okay.
I just needed to think a little bit. I will go to my complicate. Oh, sorry. This is where I wanted to be. Okay. So let's start on the right-hand side of this picture. So for ProScaleE, I think it would be relatively straightforward to basically set up a list of characterization factors based on all the information that you've seen now when it comes to the degradation factor and the hazard factor, because that would be the two factors that come into the characterization factor. So that will be very straightforward, and then it's more of a technical issue and make sure that you have the same nomenclature, so to speak. So but it shouldn't cause any problem, because basically you should be able to use the existing inventory data for processes where you have real or realistic or relevant inventory data. Of course, that might be a problem because then we would share the same problem as other impact assessment methods, basically. I think then if what the release factor model adds to the value here is that if you come across a process where you don't have data, at least you can, in a very simple way, create a simple process model, and you can enter that process as a new process, and then you can link it to the ProScale factors, because that is what essentially Rosella showed in her presentation that she did for certain chemicals. So therefore, I think that would be very straightforward. For ProScale human exposure, because we are dealing with the direct human exposure here, regular LCI databases like EcoInvent or others do not really contain information that's relevant to assess the direct human exposure. You can say that in some cases you could probably claim that the emission profile that you find in a regular LCI data would be the same even if you want to assess the human exposure directly or not. I'm not completely sure that this holds true all the time, but that's one of the issues we are going to look into. But then you would like shortcut a little bit the use of ecotoxicological TRA, and then you would rather start your direct human exposure assessment on the blue horizontal line that goes across the slide here. So it will be a slightly different thing to do. So basically what we are working on here is to create new process models for all the processes, obviously for the systems that we have assessed in various case studies, where we label them to be based on the ecotoxicological TRA estimate, and therefore particularly useful in the context where you want to use ecotoxicological TRA as the exposure model for human exposure. So that would, let's say, if you're creating, if you're doing an LCA and using regularly available data, you would then need basically to have a parallel database for the same processes, but based on the ecotoxicological TRA models. So it's a bit more work, I think, to create such data, but on the other hand, you would also add very clearly an additional aspect that could be taken into consideration in your product assessments. I think that answers, I hope that answers the question, but I would be happy to discuss that, of course, further, or we'll be able to talk more about it when we have more ready-made examples of how it works.
Thank you, Thomas. Another question for you. Does ProScale maintain a database of factors and scores by substances? And if yes, how many substances or CAS numbers are covered already?
Approximately 4,000. Meaning that all substances, and now we're talking ProScale H. We haven't completed the exercise for ProScaleE so far, but all the substances that have a harmonized classification have already a score, and it's implemented in the web tool that I showed a screenshot about. And we are working in, let's say, getting there for the ProScaleE as well. The hazard classes is very easily available, and the M factor as well. So the hazard factor part is simple. It's a bit more work to dig out the biodegradation or persistence information. So, but it's doable, and we'll get there relatively soon. And then, of course, with the help of the models that Ziye has showed, we will be able to fulfill more of the needs on other chemicals. And I don't know if you noticed, but in Rosella's presentation and the table of ProScaleE factors, there were a couple of examples where actually Ziye's models had been applied to derive the characterization factor. So somehow we will also include them, but also put a flag that they are, labeling various factors if they are based on the harmonized classification or if they are based on notification that are, let's say, not harmonized classification still. And then I guess a third category that is based on the model approach. But with this, I think we can relatively quickly increase the number. I don't want to say a specific, number, how many, but it seems to be quite doable. And what also is touched upon when he talked about the polymers is that the way that these models have been built, they are, as far as I can understand it, they are, let's say, better than other models that are out there to predict chemicals that, let's say, in other models are a bit tricky, like and another researcher in the MISTRA SafeChem program expressed it to say that these models are agnostic to the structure, meaning that you can essentially predict any type of chemical as long as you have the appropriate training set and validation set. Because if you look at most other models, they are a bit more confined in their applicability domain, as far as I understand. I don't know if Ziye wants to expand on that a little bit, maybe, how broad the applicability domain of these new models are actually.
Yeah, I can add a few comments that a lot of traditional models you can find widely used nowadays, for example, Vega or EpiSuite. These models, since many of them are trained based on some old data, some pharmaceutical data, or like traditional chemical industry data, they have a quite limited coverage of the chemical space. And since now we are using all the data enriched dossiers, it means that in the training set, the chemical space is more widely covered. And another thing is that since we are not using traditional chemical descriptors, which only works for like a small molecule, organic, and a neutral compound, now we can do more like metals, inorganic compounds, smaller polymers, and ionized compounds, etc. So yeah, the model capacity right now is much better compared to a few years ago.
Thank you for this clarification. Thank you for this clarification, Ziye. We have another question that I will ask Pearl to answer. Let me read it out. To my mind, ecotoxicity data and estimations of mixtures are exclusively based on the assumption of additive ecotoxicity or toxicity. Actually, antagonistic or synergistic interactions might be way more realistic. Can this be taken into account anyway? Huge challenge to model-based approaches. Pearl?
Yes, thank you very much, Geneviève. Yes, I fully agree with the statement that this is a challenge and it's difficult to address, but maybe I would start with the clarification. So the M factors, as currently states, we only use as a measurement or an illustration of the potency of individual substances. We are not using the M factors in the calculation of hazard factors for mixtures. So the ProScale calculation, and in particular the hazard characterization factors, it's on an individual chemical basis. I suppose what similar ways like the MAF that are going to be implemented in the EU, so the mixture assessment factor, some sort of conservative approach for mixtures could be, I suppose, implemented in a way. Maybe that's one for think about in next steps. I don't know, maybe Tomas or Rosella would like to share their insight on this. But at the moment, it's a chemical by chemical based approach, and the antagonistic and synergistic effects cannot be as such taken into consideration. Another way perhaps to address in the future, I don't know if that's realistic at this point, but if we could model the hazard of the mixtures with the software-based tools Ziye introduced, then maybe we could have an approximation of the mixture hazard that could potentially consider the synergistic antagonistic effects.
Thank you, Pearl.
If I can just
add please do.
A very brief comment there. I'm I deal with this in a very pragmatic way, I think, for myself at least, because if you think of an emission, it might be mixtures coming from a process, but when it reaches the environment and the target organisms or the endpoints there, it will definitely be mixed with a lot of other stuff. So you will always have mixtures, and it's very difficult to know what mixtures. So in practice, I think we are, at least when it comes to ecotoxicity related assessments, we are sort of stuck with the additive approach because we don't really, it would be too much information, at least at this point of knowledge, to know what kind of additive or synergistic or antagonistic effects that would occur. Of course, there are specific examples where you can show it, but in the general assessment approach that we have tried to come up with here in the first version, I think we have to stick to the additive approach because it is as right as other approaches could be at this point. Thank you.
Thank you very much, Tomas. We now reaching the end of this webinar. And just before we close, I'd like to inform you of a couple of forthcoming events where ProScale and ProScaleE will be discussed. There's one very, very close taking place next week, the final webinar of Mistra SafeChem Part 1 that will be held on the 3rd of June, and where ProScale and ProScaleE will be discussed. There's also a slot and a workshop during the Life Cycle Innovation Conference taking place in Berlin from the 3rd to the 5th of July. And there definitely will be more events in the autumn. So watch out for more events. And I'd like also to inform you that for the record, the ProScale Consortium is open for new members. We've listed here some advantages of membership, full access to the web tool and the data, some introductory training on the ProScale method and tools, support in doing a case study using ProScale, and participation in all the consortium activities. It's the useful way to get involved into the development of that methods. We have a website, easy to reach out, proscale.org. And Tomas and Rosella are available for questions about ProScale in general. So I'd like to thank you all for your participation. There's a number of attendees. I'm very happy to see that. And I'd like, of course, to most especially thank the speakers for this very informative and intense webinar, and our sponsors that were named already at the beginning of this event. Just a reminder, the recording of the webinar will soon be available, and we'll send you a link once it's online. And we wish you all a very nice afternoon and weekend. Thank you.